Alright, time for another DraftPhysics.com video presentation. So, the third installment of the lever experiment thing. And it's better, but still not quite there. So, I used a hacksaw blade, and it's not really attached to the fulcrum. So, it probably needs to be secured a little better. And I think the height has to be just right. So there are cases where it did seem to, the ball seems to leave very quickly, in some circumstances. So if it hits just right, it's like it just travels right through the blade, instantly gets the pretty high velocity, and the blade doesn't have to go all the way pushing. So it's like I said, better, but it still ain't right. And I don't think it, as a practical matter, I'm not going to be able to do this rolling two into the blade because they really don't hit at the same time. And if if you are able to get the clean contact, that is where it bangs into it and then puts all of the energy very quickly into the other ball, then hitting once and then hitting a second time isn't going to be very useful. So you can see, it takes a while for the ball to leave. The idea is that there's a couple of cases where as soon as this hits, the ball leaves. So it is capable of doing it without it being much time. The problem is the blade can twist, so I have to make it so it can't oscillate in any other dimensions. So it's got a nice hard edge, but because the balls are rotating, they push the blade down and stuff like that, and that's what I gotta get rid of. So I'm probably just going to have to go with pendulums, and it all gets kind of complicated because you have to get it just the right height to hit the center, on the center of mass, and that's sort of the tricky part, even with this rail system. So I'll probably work on that. Just first, I'll try to fix this by forcing the blade into a very straight configuration, tying it to the fulcrum, and see if that, how much of it that fixes. And we'll see. But live and learn, trial and error. There's an error for you. So let's just see if we can watch this error. Let's see what happens. So you can see that it bounced right off. So the blade didn't move at all, and this did bounce right off. So in a sense, this is a good learning experience that somehow this contact did what I want to have happen, which is I want the vibration to travel through and very almost instantaneously give the ball the velocity. So it's a pretty good velocity too. It wasn't bad considering that one of the balls didn't hit anywhere near where it was supposed to. So, interesting. Useful. Let's see what happens here. Okay. See, it still hasn't. This one hit, then hit the other ball, then this ball bounced back again. And so this is still stuck on the lever, kind of indicating it's either too low, probably too low. It's hitting below the ball. So it's not really, it didn't really hit it and push the energy into it. So, yeah, kind of lame. So it's very crude. It really probably needs to be engineered a little. See, this is pretty weak. Just let's see how much it moves. Yeah, see, it moved a lot, so it really didn't transfer very quickly. Hardly any motion on the other side, so not a good example. See what we get this time. So pretty fast. So it left quick, right? So that was pretty good. Got a pretty good exchange. The ball it left without this moving very far at all. So but this still has part of the energy still in it, which is the part I have to get rid of. Okay, I mean, this part's still going this way. Technically, it should stop. Ideally, it should stop, and all of the energy should go into the other ball. And that's what I'm after, and we're just not there yet. And such. But obviously I can't, rolling the 2 against the 1 really isn't going to work because of the whole angular problem and the separation between the 2 masses. So let's see. Almost hitting. So again, not bad, but not very good either. Pretty lame. Pretty weak transfer. But, for as simple as it is, it is showing something. So this is the 2 to 1 thing again. And obviously we want twice the velocity out of here. We're really not coming close. Okay, so you can see the separate, they just separate, and that's, ain't gonna work. So the first one hits, then the second one now hit behind the first one. So it's not terrible because this hasn't left yet, but the fact that it hasn't left yet means the energy didn't go right into it. So yeah, it's having to push it for quite a while before it finally leaves. And it's a pretty good velocity, but it's not nearly enough. It's pretty bad actually on that case. Maybe this next one will be better. Okay, pretty quick going in. It hits. Yeah, see, hit twice, and so this one's just getting pushed, but it's pushed pretty slow. So that didn't work at all. Last one, I think. So yeah, it didn't, no instant movement, nothing, kind of lame. So again, just really has to be right on the center, and I obviously don't have this on the center of the mass, and so that's one of the biggest problems I got to fix. All right, so that was really not even good enough for measuring. Not there yet. So see if there's a better picture here. Just see what this one was again. Yeah, that's the side. See, so the sideways one was interesting. As you can see, it left right away. It's already gone. It's on its way. I guess the fact that this ball hit on the other side of the fulcrum stopped this from moving. Okay, this one. So this one couldn't push this way because this one hit on this side of the fulcrum, which is sort of interesting. But it did move pretty good. It's not a nothing velocity. It's not much of a velocity, but anyway. We'll see. Just, next version, I might just resort to doing the spring thing, but we'll see. Because it really is hard to get all of the energy into the other side of the lever, because something always weighs a little bit more, or something's always in the way. Like I said, this rail thing is sort of imperfect, because that's another part where it doesn't hit the same surface. It sort of goes against the surface and then slides across the surface, and that's not ideal either, as you're technically not putting the energy in the right direction. So it'd be better if it was a perpendicular contact. So that's something else to consider as a problem, and certainly there'll be friction on that edge, so that's another problem. So lots of problems to work out yet. So some other version might be the way to go, but I'll fiddle with this a little more just because I like it. But we'll see. So anyway, that's it. So till the next time, and such.